At Domo, we've built the industry-leading self-serve analytics platform that enables anyone, not just technical experts and senior business leaders, to unlock value from data. Variables expands Domo's capabilities by giving content creators the ability to turn static dashboards into dynamic, interactive data apps that are easy for anyone to use. We know users often have multiple questions in mind when exploring cards and dashboards. For example, let's say I'm looking at sales and I want to compare the impact of one product to the total revenue. Then I want to switch to seeing unit sales instead and compare that quarter over quarter for the past 2 years. Now I'd like to filter by region and see what happens when I swap in a different product. Well, what if my dashboard wasn't built to answer all these questions? I would be left searching for answers scattered in different places and possibly needing to submit tickets to my data team for ad hoc reports. This can lead to delays, mistakes, and sometimes a loss of trust in data and data teams. BI analysts can't predict every question, and with variables, they don't need to. Variables allow data consumers to surface their own insights with confidence. From what-if analysis to metric exploration, time comparisons, and dynamic pivot tables, variables provide the building blocks to replace static dashboards with interactive data experiences that allow any user to generate insights on their own without relying on the data team. So, what is a variable, and how does it solve this problem? A variable is an object that stores data for use in dynamic beast mode calculations. Variables are controlled inside of cards and dashboards by familiar components like sliders and drop-down menus, giving end users the ability to manipulate visualizations on the fly. Now some members of the Domo team will illustrate some of the solutions that variables provide with 2 use cases. After that, they'll explain how to create and implement variables in your own cards and dashboards.
When looking at data, decision makers often want the ability to model outcomes based on different assumptions. This is commonly referred to as what-if or scenario analysis. And variables makes it easy to deliver this capability in a self-serve format for business users. Consider this scenario. You run retail partnerships at an apparel company, and you want to analyze how 3 key business levers, your advertising discount, your shipping costs, and vendor inflation, will impact the overall margin that your vendors will receive. And let's also assume that you think about your products in terms of 3 categories: athletic apparel, dress apparel, and sandals. So traditionally, your vendors have demanded about a 25% margin. But what if that's up for negotiation, right? What if that's expected to change and increase in the near future? You want to be able to model that scenario and understand the changes that you need to make around that reality to adjust your business accordingly. So let's say that margin is going to increase to 35%. Well, you can model that in this dashboard. So you enter that new margin goal input using the variable, and you can see your card dynamically updates. And now I can start playing with some of my business levers to understand how I can make up this gap. So the first thing I might think about doing is decreasing the advertising discount I'm offering. So let's push that to 10% and see what happens. We've moved a little bit closer to 35%. Now, what if shipping costs lowered to $10? Now I'm a little bit over. Let's move that to 15. Okay, and now I'm right around that margin. For each vendor, I'm at 34%. I can make smaller adjustments with these inflation levers. So now I know, right? I can tell from the card that I'm pretty much right on goal for each of the vendors and all of my product categories. So as you saw, the entire card updates when I adjust a variable control. And that's because each of these variable controls is adjusting a calculated field that's powering the data set in this visualization. So instead of, heaps of cards spread across cluttered dashboards, you have a single interactive view that can easily be explored by anyone. And as a non-technical, non-data person managing our retail partnerships, I can now use this tool to decide how to approach ad discounts and shipping costs before the shipments go out. And this way I have a really accurate forecast of where my key metric of vendor margin will fall. How about exploring historical business data? Maybe you want to look at a couple different sales metrics to gain a better understanding of how you've been operating, and you want to be able to adjust that data across many different dimensions. Using variables, you can create a self-serve experience that accomplishes just that. You'd start by choosing from one of 3 different types of sales metrics: units, orders, or sales by revenue. And then you can drill into this data, much like you would with a pivot table in a spreadsheet, but only in an intuitive visual experience. So let's say I'm interested in understanding how my apparel sales have been trending in California. First, I'd choose the type of sales metric I want to see. Let's say I'm interested in units. Then I'd select state. And then I'd select apparel as my category variable. And then I can filter this down to California. And when I make those selections, I can see them visualized in the bar chart. I can also see the monthly breakdown here in this horizontal bar. And there's even to-date summaries at the top by year, quarter, month, and week. It's also built to show the comparison versus previous period, as you can see. And if I want to swap out the type of sales metric or any of the dimensions, I can do that easily with just a few clicks. So let's say I want to switch to revenue, and maybe I want to drill further into the different cities in California that we operate in. So now you can see the card is updated to show me the sales by revenue broken out in LA, San Francisco, and San Diego. Now, another thing you'll probably notice here is variable smart text. The text is automatically updated to the variable that I've selected to ensure that the data is being communicated accurately in words as well as numbers. So if I change this metric to units, you'll see all of these dynamically update at the top here. Instead of struggling with a clunky pivot table or asked to create different cards and visuals for all these combinations of metrics and dimensions, you build the solution to fit the whole business scenario up front. And this gives the end user the freedom to do their own analysis without relying on a data person for every change that needs to be made. And once you've determined the variable settings you use the most, make it easy on yourself by saving those views for next time in the filter menu. With metrics exploration, variable smart text, and variable views, extracting insights from data is more powerful, flexible, and self-serve than ever before.
We've illustrated the power that variables delivers to creators and consumers of data products with 2 examples. Now, let's look at how you can build solutions like these using variables in your own Domo instance. Let's start with a simple example to guide our explanation of how to build and implement a variable in Domo. We're going to build a view that displays shipping cost per unit on a card that can be adjusted with 2 sliders, shipping cost and subsidization rate, both of which are powered by variables. To find variables, open Analyzer and click Beast Mode. This will drop you in the Beast Mode editor where variables live. Here, you can click the Variables tab to view all the variables that have been created. Variables are global, meaning they can be used across datasets, cards, and dashboards. All users will be able to see and use all the variables in a Domo instance here in the global list. This means you don't have to create the same variable more than once, which can be useful for when they get more complex. As part of this release, we've made enhancements to the Beast Mode editor to better support variables. Multiple tabs and a larger Beast Mode editor window are a few examples of these enhancements. Start by clicking Add Variable. There are a few key elements to define: the variable name and description, the data type, default value, and default control. Let's call this new variable shipping costs for now. Variables can be defined as dates, text, or numbers. We'll create this as a number variable and give it a default value of 10. Let's add a default control for this variable. Here you can choose from different controls depending on the data type of variable you chose. Let's select Input Slider, give this control a maximum value of 20. We'll keep the step size at 1, and we'll format this control as a currency. Next, we'll select Create Variable, and we can see our variable populate in the Controls rail in Analyzer. It's important to consider the design pattern you want to apply when creating a variable. Generally, you want to create variables for values that will drive your analysis. For example, if you're setting up a what-if analysis, which is really a model for an experiment, you would create variables for each independent variable in your experiment. These are typically your key business levers. After a variable has been created, it can be referenced in calculated fields known as beast modes. The value that gets passed into those calculations is modified by the control element linked to it. In this case, our variable called shipping costs, as well as another variable we've created called vendor subsidization rate. Let's create a new beast mode calculation. We'll name it shipping cost per unit. We've added the shipping costs and subsidization rate variables to this calculation. By default, these variables will be equal to their respective default values, which are $10 for shipping costs and 25% for our subsidization rate. When I adjust the slider control from the card or dashboard, the new value from the control will be passed into this calculation, updating the default value. We'll create this calculation, then drag it into our card, and I'll format the column as currency. We can see that with an overall shipping cost of $10 and a vendor subsidization rate of 25%, our shipping cost per unit for us comes out to be $7.50. Let's say the overall shipping cost per unit increases to $12. In order to keep our costs below $8 per unit, we might have to raise the subsidization rate to 35%. These calculations can be as simple or complex as suits your needs. It just depends on the type of solution you want to implement. In the vendor margin use case discussed earlier, we can see that the beast mode calculations being used here are a bit more complex than the shipping cost per unit example we just created. This calculation includes 3 different variables and involves quite a bit more logic in the calculation. To dynamically swap multiple cards to a different dimension or metric as we've seen in previous use cases, I can create a text variable with different available values for the user to select, and then build a case statement in my calculated field that will use a different column depending on the user's selection. Let's take a look at the choose dimension variable. This is a text variable with the default value of region. The control includes the available values region, state, city, brand, category, and department. This card is using a beast mode named beast mode dimension. Let's open up this beast mode calculation to see how it was created. This calculation uses a case statement, and we've added a separate condition for each available value in my variable. When the value category is selected from the variable control, this calculation will use the product category column in my card. Watch as I update the variable drop-down control from region to category. My card will update to use the product category column in the x-axis. Now that we've added a variable to our beast mode and used it in our card, it's time to use this card and variable control on a dashboard. Any cards on this dashboard that are using a beast mode containing the variable choose dimension will be updated by this dashboard variable control. Watch as I change this variable control to a different value. We'll change the dimension from region to category, and all the cards using this variable will update to reflect the new value. To add a new dashboard variable control, we'll edit our dashboard, add a control, select the choose metric variable control, and save our dashboard. Watch as I update this variable control from sales to orders. All the cards on this dashboard using this variable will update to now show orders. You'll notice that once I change a variable control from the default value to a new value, it appears in my page filter bar above. Here I can adjust the variable and save the variable values alongside other filters as part of a filter view. You can also use variables to power smart text and notebook cards. By putting the variable value into a card title, description, or a notebook card, it dynamically changes as the variable value is adjusted. This allows you to link text to variables. As I update my dimension and metric variable controls, watch as the card titles update to reflect the new values and more accurately display what data is being shown in the cards. As I update the variable from units back to sales, watch as my card titles update to reflect the new variable value. To add variable smart text, we'll edit our dashboard, edit the card title and description, select the smart text option, and select the newly added variable type from my list. Here I can add any variables being used on this card to my card title or description. Similarly, I can add variable smart text to a notebook card by editing the notebook card, selecting smart text, then the variable's type, and here I can add any variables being used on this dashboard. We can use variables in a pivot table to dynamically change out the columns, rows, and values being used in the table. Notice that variable controls are available in the new story presentation mode alongside quick filters in the controls rail. Watch as I change the column from brand to category, and the rows from region to state, and state to city. We'll update the metric from sales to units. With variables, charts, tables, and pivot tables become dynamic, enabling users to explore different views of their data. Variables are also available in embedded cards and dashboards. Here we can see the same dashboard using variables embedded in a separate web page using Domo Everywhere. Watch as I update advertising from 5% to 10%, and watch as my cards update to reflect the new variable value. In addition to the benefits data creators and consumers get from variables, we've included features that make governing the use of variables easy for Domo admins. The first is the new variables grant, which controls who can create, edit, or delete variables. This is turned on by default for any roles that currently have edit cards enabled. Any users that are able to create visualizations in Analyzer will be able to create variables. Domo admins have the capability to turn this privilege off for certain roles using the variables grant. Users without this grant will still be able to use variables in their beast modes and interact with variable controls on cards and dashboards, but they will not be able to create, edit, or delete variables. Similar to the variables grant, we've also added variable lock, which gives a variable creator the ability to lock their variable from further changes. If you have a variable that you don't want anyone touching, you can simply lock the variable the same way you can already do with beast modes today. Only admins and the variable owner can change the default settings, but other users will still be able to use this locked variable in beast modes on cards and dashboards. In addition to controlling who can create, edit, and delete variables, admins also need to know how variables are being used across a Domo instance. So, we've added a few different Domo stats reports to help you manage your variables. To access these reports, navigate to the Connectors page and choose the Domo Stats connector. We've added 3 new Domo Stats reports related to variables usage. The first report is the Variables report. This will show you any variables that exist on the instance along with information such as the variable name, ID, created date, and owner. The Variables used in Beast Modes report provides insights into which variables are being used in different Beast Mode calculations. Lastly, the Beast Modes used in Cards report provides the Beast Modes being used in cards and the corresponding card IDs to which they're being used in. Using these 3 reports together, admins can get a full list of variables created in the instance, the beast modes that those variables are being used in, along with the cards that those beast modes and variables are being used in. Here, I'll walk through an example of how variables can be used for custom period-over-period analysis. We can see the total sales by region for a business in this chart. Across the top, we've created a few custom variable controls with different options to change the date range, week to date, month to date, quarter to date, and year to date, as well as the type of comparison, year over year, and period over period. Users can select between these different options to see a different date comparison. Watch as I change this chart to show sales month to date, period over period, to month to date, year over year. Then I can change it from month to date to year to date. To do this, we've created 2 variables. The first is the time range variable with the options week to date, month to date, quarter to date, and year to date. We've also created the time comparison option variable with the available values year over year and period over period. We've then used these variables in calculated fields using nested case statements. In the current time range calculation, we've included a separate condition for each time range option, year to date, quarter to date, month to date, and week to date. Depending on which options the user selects, we've added the appropriate custom date range logic. In the comparison time range calculation, we've added an outer case statement to check whether the user selected year over year or period over period comparison. With each of these options, the calculation contains a separate condition for each time range option similar to the current time range calculation. Using variables, users can add custom logic for period over period analysis to suit their exact business needs. Similarly, in this example, we've created a chart where users can select specific start and end dates to compare. This is done using the date variable data type. Watch as I select different start dates for my comparison. We'll change the start dates from January 1st to January 15th. To do this, we've created 4 date variables for the example: start and end date for the first date range, and start and end date for the comparison date range. We've created these variables with the data type of date and given them a default date value. We've then used those variables in 2 different calculated fields, one for the current date range and one for the comparison date range. Here we are only displaying sales data with an order date between the start and end date variable values. With date variables, users can select specific dates for custom time comparison. Hopefully these additional examples show you how features and use cases come together to deliver an interactive experience for the end user.
We built Variables to give analysts and business users the tools to create interactive, self-serve data experiences, increasing speed to insight, reducing reliance on IT, and saving everyone time and resources. We hope the examples we've shared in this video will help you leverage the powerful analytics capabilities that Variables brings to Domo.